For those of you already in here, you figured out I turned off the waiting room, so you don't have to get admitted that way anymore. I also have it set to mute you by default when you come in, so just be aware if you go to speak up, you got muted when you got added to the meeting by default, or should have anyway. We'll get started here in just a minute, but I'm here, so if anybody's got any burning questions and wants to just shout them out, we got 4 minutes of unstructured chat before I dive into the markdown that's on the screen. Slack channel up here. Okay, cool. And my screen's all set.
I have a question for you.
Yeah, fire away.
Um, what would be the best way to keep practicing? Because when you do it on Free Code Camp, I feel like I understand what I'm doing, but when I go to do it for like to do it by myself on like VS Code, it's
Mhm.
a lot different.
Yes, that is so there's a phrase known as tutorial hell, and you're getting the first taste of it. And we want to get you out of that as quickly as possible. Obviously, this OK Coder is being focused on being sort of an intro, and we're not doing, 40 hours a week of full-time coding in here. There's going to be an inevitable amount of kind of staying in a learning mode for, a quote unquote beginner learning mode for a lot of that. But what I mean when I talk about tutorial hell and what that's kind of known as is um, it is really easy to fall into the trap when you obviously when you first start learning tutorials and code and sort of hand holding courses like Free Code Camp are super useful and almost kind of required. But what happens is if you don't find ways to break out of that soon and often, you get in this habit of like, cool, the way I learn everything is by doing another tutorial. And you're experiencing the exact problem with that. So there's a fundamental difference between doing a tutorial and doing something on your own. And that fundamental difference is in the tutorial, all the decisions have already been made. Whether they give you the answers or not, there's still a sort of very well-defined target. All the problems of the app have already been solved by whoever wrote the tutorial. And so there's the entire component of you having to actually figure out how to solve a problem that is kind of taken away from you in a tutorial by design to make it, approachable and learnable. So my general advice for breaking out of quote unquote tutorial hell early and often is the sort of baby step is that after you do an exercise via some code along tutorial or YouTube course or free code camp or whatever, open yourself up a blank new project in VS Code and see if you can build the same thing again without the tutorial. And it doesn't have to be exactly the same. It's actually kind of more fun if you decide to hack on it a little bit, add a feature, change something, make it look completely different, whatever it is you're interested in working on. And I suggest letting your curiosity drive that a little bit, because things you're inherently interested in, you'll be more motivated to learn and you'll learn them quicker. And with where most of you are at, you have an almost infinite amount to learn. And even after you learn all of that, there will still be an almost infinite amount to learn because this field is so new and continues to change every day. So part of what you also need to build up if you're interested in being a developer as a profession is kind of always being in that learning mindset. Like you will always have new stuff to learn, and you will always have new problems to figure out. And so the more you can kind of take training wheels off and force yourself to just practice that skill, the better. And it is a big leap to suddenly have the tutorial training wheels taken off. And I think, Philip, you're expressing something that often catches people by surprise. They're like, oh yeah, I totally understand this whole thing. I just did this 18-hour YouTube course on JavaScript. I know JavaScript. You open up a blank JS file and you're like, I have no idea what I'm doing, right? And you actually do know what you're doing. It's just that there's this whole step of having to go from an empty file to putting some stuff in it that you haven't had to do yet because the tutorials have all been doing that for you. So my advice is just start building new projects, and they can and should be extremely small at the very beginning. So think of the simplest little, we're all doing browser JavaScripty stuff right now. So like build a super simple single page HTML file with some JavaScript in it and see if you can make it do something. Build a button that changes color, or and there's lots of good examples too. You can kind of Google like good beginner JavaScript projects, but don't actually follow tutorial. Just look what they built and see if you can figure out a way to attack it. But it's critical that you go into a nobody's told me how to do this part yet, and I'm just going to go figure it out with what I already know and the help of Google and AI and whatever else you're going to use, right? So I think part of that frustration is just actually learning the skill the tutorial doesn't teach, which is how to go from nothing to something. And that just takes practice. So the more you can build, the better. This is also a great excuse. I'm going to do a shameless plug for practicing Git and GitHub skills early and often. We haven't really talked about those at all in this module, and we probably won't a whole lot, but I'm happy to dive into that with any of you if you want to DM me about it or ask questions about it in the channel. And I know Brian's posted some videos and stuff already. But that's something that is like a real world skill. You're going to be working in source control ideally wherever you're applying these skills. And so if it's a habit you build early, then it just becomes part of your workflow. Oh, cool. I'm doing, my little coffee shop project. Great. All that's getting submitted and pushed to GitHub every time I make changes. The same, and that's kind of the same idea with this, where I'm getting at with these like building small projects. Just ask a friend what would be a cool little tiny app for them to have. Think of something you would actually use. If you have some way to actually create a user story or something that's just an interesting puzzle for you to solve, that's great. And it can literally be one JavaScript file or a JavaScript file and HTML file. I'm not talking about building giant complicated apps with databases and all this other stuff you'll get into later. But it's just the act of starting from scratch, I think is absolutely critical. And there's lots of good ideas out there. If you don't have any, or just ask ChatGPT or something like, hey, what would be some good topics or challenges or ideas? So as far as like project stuff and that experience of opening VS Code and feeling like you knew what you were doing until you did that and didn't have something telling you what to do, that's my answer, is projects. If you want just more like kind of lower level specific technical practice on just JavaScript methods and properties and stuff like that, I also recommend looking at things like Advent of Code or Exorcism. I'll drop those links in the chat real quick here. Advent of Code, if you're not familiar with it or haven't heard of it, is a puzzle competition that comes out like an advent calendar in the December season for Christmas every year. So the first puzzle gets launched at December 1st at midnight, and there's 25 days of puzzles, but and they get progressively harder. All of the like day one, day two stuff are great fun brain benders for intro JavaScript stuff. And then, see how far you get. But they host the last, I think all the way back to 2015, they have previous events up there. And those are all like single file, single problem, single puzzle to solve. And in that case, the puzzle is laid out for you, but how to solve it is not. So you still get that having to solve something from nothing, but with a little bit more boundaries set up for you, so to speak. And the other one I'm going to shamelessly plug here is exorcism.io. So I just dropped both of those in the link in the cohort channel. Exorcism is similar. You may have heard of LeetCode or Code Wars. There's several of these other ones out there that are basically like data structures and algorithms puzzles. They often get used in technical screenings during hiring processes, which is one of the reasons why people study them. I don't think that spending a ton of time studying them is your best use of time currently, but it is inevitable that you're probably going to run, if you're trying to get a job in this field, that you will run into a technical screening at some point where you're going to get thrown those kinds of puzzles. So having some exposure to them is good. And they're good brain practice. The reason I plug Exorcism.io specifically is because I love their approach to it. LeetCode and Code Wars and those are useful, but if you're not in a sort of competitive puzzle solving mode, you get no other help and no other guidance. They're not tied really to user stories or anything like that. It is very specifically like, how do you solve this mathy problem in a programming way in the most efficient way possible kind of stuff. And what Exorcism does is it tends to wrap those puzzles in a small story. So it's a little more clear why this might be a useful thing to figure out, or at least a little more interesting to play with. The other thing they do is Exorcism has a CLI tool you can install. That's command line interface. If you don't know that acronym, just means something you can type in the terminal and make stuff happen. So Exorcism gives you a CLI option and you can install it, and then it all works with Git. So when you pick a puzzle out you want to do, you can Git clone the puzzle, and then you can Git push your submission, and it runs automated testing on it to tell you if it passed. But you can also run that automated testing locally. And that gives you a chance to look at what automated testing might look like and how that whole scheme that I'm a huge fan of, but we're probably not going to have time to get into in this module, works as well. And they also have learning tracks. So you all could like go over that, and it's a free nonprofit, no paywall, anything site, which I also appreciate. So you can hop on that Exorcism.io, join their JavaScript track, and it does work you through progressions of concepts, trying to go from easy to harder. But you also get that chance to actually like do the puzzles in VS Code if you want, using that CLI tool and Git instead of doing everything in an editor, which gives you a chance to kind of play with that tooling a little more also. So those are my two favorite go-tos. I know JavaScript pretty well at this point. I get paid to write it, so assuming I'm probably somewhat competent in it. But I still go back to those all the time. Because I love solving puzzles, so I work on the harder ones. But I also use those as tools that are very useful when I want to learn a new language or framework that I haven't played with yet. Because if, for instance, I've already solved, Advent of Code 2023 day one in JavaScript. So I kind of have an idea of an algorithm to solve that particular problem, but I'm currently learning Rust. Going back and doing the same problem in Rust means I'm not trying to figure out the core idea of how you crack this puzzle. I'm just figuring out how you do it in Rust, and I already have done it in JavaScript. So now I can focus on learning the Rust parts, if that makes sense. So useful for brush up, useful for interview prep, useful for kind of cementing just basic syntax stuff and playing in your editor. And those are my two places I tend to go more than any other for that kind of practice. Otherwise, I just build stuff, have an idea, start building it. If you never finish it, it's okay too. I build stuff all the time just to learn something and see like, hey, I think this might work this way if I assemble it like this. Take a swing at it and you learn stuff. And then you know more about what you don't know, which is also important to figure out. It really is its own skill that I think often gets under communicated when people are trying to either break into this industry or learning it. If you're actually moving towards writing software for a living, a huge part of your job ready skill set is being able to figure out what you do and don't know in any given context, and then how you learn the things you don't know that you need to know, and then going to learn them and being comfortable with all of that stuff you don't know and having processes for approaching it. Because as much as it may seem right now, like if you just do enough of this, eventually you'll know all the JavaScript methods and then you'll know JavaScript. They will change JavaScript. That'll be a thing that'll happen. But also, there's all of these other things involved in building a product people will actually use, or an app you're actually going to use, or a fully fleshed out tool that you don't really experience until you actually just try to build one. So the more of that you can do, the more you can get in those cycles, the more you'll figure out kind of which things you are and aren't comfortable with, and which things you do feel comfortable with. And then, of the things you don't feel comfortable with or are clear that you don't know, when you identify those, do your best to kind of decide how important you think it is to learn them. Is it a core method of dealing with strings and arrays and whatever? Probably useful for you to understand better. If it's some esoteric thing buried 30 pages of links deep on MDN, you probably don't need to worry about it yet. And then once you've kind of triaged that, spend your practice effort on learning the things you think are most important that you don't know yet. That's kind of my 2 cents on all of that. Hopefully that is all helpful.
Thank you.
You bet. I love talking about this stuff. I love talking about learning. I love talking about code, and I love solving problems. So anytime, it won't be hard for any of you to derail me into that sort of topic anytime you want to. Just ask a question. I also thoroughly love questions. And yes, Jonas just responded to the thread in there. 100% recommend Exercism over LeetCode for all of those reasons. The only benefit LeetCode has over Exercism is it has way more puzzles and way more solutions on it in the long run. So if you're trying to really grind for a highly technical interview somewhere, there can be some merit in that. But for general learning purposes and workflows and getting used to your editor and getting all that, I think Exercism's approach is like way better. And the lady who founded it is also very cool. So there's that. Okay, let's get into some stuff today. Before I dive into what is hopefully not entirely new material, because again, we've shifted this just a tiny bit with this new beta curriculum from Free Code Camp. So you're getting kind of like, you got introduced to everything in the Dragon RPG that we're going to kind of do in the whole module. And then in the next exercise with the form validation, you're touching a lot of that stuff again with a few little new things sprinkled in. And we're going to kind of keep that pattern going. So hopefully functions aren't completely new to you at this point, but we're going to dive into those more today. Before we do, does anybody else have any pressing questions currently on the Dragon RPG or the form validation exercise? If there's something that really just isn't clicking at all that I can be of help with, I'm happy to take a few minutes on that. Okay. So let me talk briefly so I don't forget to do it at the end about homework stuff. The form validation exercise, if you haven't finished it yet or dug through it, it is another long one. It's about the same length as the Dragon RPG. Hopefully a lot of it is a little quicker for you than the RPG might have been the first time around, since things like functions and variables won't be new again, hopefully. But they do introduce some new things like regex literals, which we're not going to get into today too much. But I'm going to give you one more today, which is the next exercise in that Free Code Camp stuff. And I know that given that we're not really doing, like, I'm not collecting homework, we're not grading things, etc., and that you all have lives, and I have no idea what your actual real hour-to-hour investment is in your homework in between classes here. This is here for you. So take that as it is. The homework after today will be the next exercise in that beginner Free Code Camp curriculum, which is building a music player. They've done all the HTML and CSS for you for the most part, so it's just adding the JavaScript methods to make it interactive, but it's a really nice review of strings and arrays and all that stuff. There will not be another free code camp exercise assigned after Saturday's class. Saturday will be a build day for you to work on the next phase of your coffee shop app. So we'll go over that at the beginning of Saturday, and that will be all you'll work on Saturday. And then from Saturday to next Wednesday's class, the only quote homework is review anything you want to review, and I'll give you a few more useful links for that on Saturday. And do any catch up you feel like you need to do on the free code camp exercises at that point, and or your coffee shop post build day. So we won't be adding any new quote assignments after Saturday. So you'll have those 5 days from Saturday to Wednesday to kind of catch up a little bit. But I'm going to give you another one today. I just didn't want anybody to panic if you haven't finished the form validation, and I'm piling another one on you. We're going to get through 6 of those all together in these 4 weeks. So that'll be number 3. We'll take a break and then we'll come back. Okay. Any questions about any of that before I move on and actually get into functions? Awesome sauce. Also, if any of you came in right at the last minute and missed it, I did make some adjustments to the Zoom meeting, so no waiting room anymore, which you all hopefully noticed and appreciated, because I know I did. And also you all get added muted by default now, so that when everybody comes in all at once, we don't have 30 open microphones or whatever. So if you've been trying to talk to me, you've been muted, just so you're all aware. All right, that said, I'll leave a couple minutes here for some questions if we have any. All right, cool. At any point, feel free. I think I can see like the Zoom raise hand thing. I've got my screens all arranged all over the place. But you know, if not, if I miss you, just unmute and shout and get my attention. Start with my name. That's probably the easiest thing. But interrupt me at any point here with questions and stop me. I like getting derailed into interesting questions. So. Okay, let's talk about functions. I may teach functions a little different than Free Code Camp approaches it, which was to just have you write them and or tell you they're reusable code. I start with something I think sometimes people think is, I don't know, maybe a more technical or advanced or lower level aspect of functions, but I actually think it's kind of the single most important thing I can teach you about functions. So that's where we're going to start. And that is the idea of a function signature and how to read one. So you've all already written one, whether you've realized it or not. You've written several of them. When you declare a function, and here is the function declaration syntax, right? With that, I've added some notes in here, so don't get too confused by that. But function, some name for the function, some parentheses, and then some curly braces, right? And you may have been putting your opening curly brace on the same line as the function declaration, which is fine. JavaScript doesn't care. I write them this way because I think it's easier to read. That's that. You have officially, whether you knew it or not, created a function declaration and therefore also defined the signature of that function. So if we think just about the etymology of this, your signature is unique to you, right? That's the idea in theory of a signature, is like you sign a document, you sign your driver's license, whatever, like this is the thing that explains kind of like who I am and how I'm identified. Well, function signature tells us 3 basic things about the function, and it is all written in the declaration line. And in some other languages, you just declare a function and then you implement it somewhere else. In JavaScript, typically you declare it and implement it at the same time. But when you declare a function, you are saying this is the signature of this function. And those 3 key things are the name, any parameters, including their types, which in JavaScript it infers, we don't specify those, but you still need to think about it. And we'll talk about that in a second. And then its return type. Those are the 3 things that make up a function signature: name, parameters, return type. Okay. So when we read this as a signature, what we're saying is I have a function named descriptive function name. It takes the following parameters, which, remember, even though you don't write them in JavaScript, all have types. So this function may take a string, or it may take a string and a number, or it may take 2 numbers, or it may take 6 numbers. That would be a code smell for me. We'll talk about that later. But both the order of the parameters and their types matters, as well as what name we want to use for them when we're implementing the function. Okay. So that's all the stuff about parameters. You may have also heard the term arguments, and this is one I know sometimes people kind of confuse a little bit, and don't worry too much about it. You can use them sort of interchangeably, and generally we'll all know what you mean. But the difference between a parameter and an argument in function land is it's a parameter here when I declare the function, and later if I call the function by writing, descriptive function name with parens in it and pass it something, that thing I'm passing it when I call it is an argument. So you define functions with parameters and you call them with arguments. That's the sort of distinction there. And part of the reason that that is a distinction is that when we're defining parameters, we're not giving it a value, right? I'm just saying this takes a string and I want that string to be called username or whatever. But I'm not actually giving it a string here. I'm not giving it the value Eric Kyle as username. So arguments will have values and parameters will not. Parameters will only have types and names. Okay. And then there's a return type here. So a return type is simply when this function runs its code, what type of value am I expecting it to return? You have not seen this syntax at all in JavaScript yet because you can't write it in JavaScript. You cannot specify the return type of a function in JavaScript. You can if you use TypeScript. But I'm writing it this way because I think it's important to understand that this is still something that the language is inferring. Okay. Now, my function currently returns nothing. So given our knowledge of JavaScript types, what is the return type of this function currently? As written, which does nothing. Anybody know?
No.
No.
Close. It's going to be the other cousin of null because
In undefined?
yes, sir. It will be undefined because I haven't returned anything. For it to be a null return type, I would have to actually return null. So again, remember that distinction for us is kind of that null should be used as intentionally saying there is an empty value here. There is nothing here. Undefined is meh. We don't know. And this function doesn't do anything and it doesn't return anything. So its return type is undefined. There is another very common return type specifically for this purpose across a multitude of languages, and it's known as void. So if you ever see something in code about a function that returns void, what it means is that function doesn't return anything, which again is different than returning null. We could explicitly return undefined, but that would be really weird. You don't generally ever do that in JavaScript. But returning null is totally a valid thing. Okay. So the reason I think this is the single most important thing you can understand about functions is that this will tell you how to use any function you ever come across in JavaScript for the rest of your life. So that seems pretty useful to me, including new ones they haven't added yet. Let's take a look at a quick example of what I mean by that. I was looking at regular expression stuff earlier. I'm just going to pick a random function that uses regular expressions. Great. The match function, which we can call on string objects. Don't worry about the prototype part here. This is largely because of that thing I mentioned on day one, where when we, or maybe it was on the second week, where when where you have a string that is a primitive value, but then you can actually call methods on it, and primitives don't have methods, but it gets wrapped auto-boxed in a string object. That's capital S, and it is the prototype of the string object that has all these methods on it. Okay. So you can kind of think of the prototype as like the parent or the, it is literally the prototype. It is the thing from which we create all string objects. So they all have some common set of methods and properties. But if I go look at string prototype.match, let's scroll down here just a second. Oh, look, we're starting to get a function signature spelled out for us, just not with all the notation I did, because you can't actually call out types in JavaScript that way. So here is the syntax. Match, and you patch it a regular expression. But now, oh, look, all those things I just said, the parameters and the return value, okay? So by being able to read this and understand, okay, if I'm ever going to call match, the only thing I can ever pass it is something that is of this type, which is a regular expression object, okay? And it has to have a symbol.match method. Cool, so anytime I want to use this, I got to pass it one of those. It also tells me what happens if I don't give it any. It's going to match on basically this regex here, which will mean something to you and when you get to that informed validation if you haven't yet. And then in addition to telling me what I have to pass into it and what type those things should be, it also tells me what I should expect back. It's going to return an array. So now I know wherever I use the return value of calling that function, I'm going to have an array to deal with. So I can use array properties and I can use array methods. I can also do things like error checking. Like if I don't get an array back, something's gone wrong, right? And then you get into descriptions and details, okay? If I just pick some other random method like replace all, okay, so we now have a new syntax. This one takes 2 parameters or 2 arguments when we call it. So here we're calling it, so these are gonna be our arguments. We're gonna pass in a pattern and we're gonna pass in a replacement. Pattern has a type. It can be a string or an object with a symbol replace method, which is usually a regular expression. So string or a regex here for the first parameter. The second one, the replacement, can be a string or a function. So we can pass a function to a function. We'll get into that a little bit more in a minute. Okay. So this tells me the valid things I can call this function with, and also by exclusion, all the things I can't pass into this function. And so if you're ever writing some JavaScript and you're trying to use a method on something or a function on something, and it's not working the way you expect, the first thing I always check is, am I using the signature correctly? Am I passing in the right number of arguments of the right type? And am I treating the return value like the type that it's going to actually return? So like if you're expecting a string back, but you're using a function that returns an array, nothing you're going to do with it is going to work right. And that's your immediate clue. You don't have to know anything about how the guts of the function work to figure any of that out. So it is super powerful when you're reading code to be able to just take a second and look at the function signature. Number, order, and name of parameters and their types, and what does it return? Okay, so that's my long soapbox about the importance and value of function signatures.
Quick question, is regex, is that part of JavaScript or is that kind of something additional that is used in JavaScript, if that makes sense?
I'm going to say yes to both. So regex is a broader concept that is implemented across almost all programming languages.
Okay.
Each programming language picks their implementation of it. So not all regexes are identical. They're all pretty similar and they use pretty similar patterns. But for instance, there's something called look ahead or look behind you can do in a regex in JavaScript that you cannot do in a Rust regex because it doesn't implement that functionality. So when you look at that site that I linked briefly last class, because you're going to hit a regex in that form validation exercise, you can see right here on the left, there's this flavor section. So there's PCRE2, PCRE version 1, ECMAScript, Python, Golang, Java 8, .NET, Rust, etc., and a guide to all those flavors. So ECMAScript right here, that is the flavor of regex JavaScript uses.
Okay.
Okay. It will work almost identically to a PCRE regex, but with tiny, tiny little distinctions. So generally speaking, when you learn regex, you'll kind of learn regex, and you don't have to think too much about it being JavaScript specific. But I do just point that out to know that if you ever go to another language and you get something weird in regex, it might not be that you're not understanding regex correct. That language may just have a slightly different flavor of it.
No, very helpful. Thank you.
You bet. Okay. So there are 2 ways in JavaScript to create a regex. There is a literal. We'll look at these real quick. A regex literal would be something like the right one that's interesting. Let's go say /d 5 and close it. Okay, so this will match any string that is 5 consecutive digits. And the reason I know this is a regex literal, and this is pretty common across all the languages that implement regex also, is because it is trapped between 2 forward slashes. Okay. So the internal bits of this is just a string-based pattern. And then you just wrap it into externals. The other way I could create the same regex would be to use the regex constructor, and we haven't really talked about regex constructors yet. That takes a string as an argument. Hang on, I'm going to show you function signatures. Oh, look, here's TypeScript helping me out. By the way, your VS Code will do this also even when you're not using TypeScript, because VS uses TypeScript under the hood. So just by hovering over new regex, I can see it's a constructor. And what it does is it takes a pattern, which needs to either be a string or another regex object, and it will return a regex object. Now I know how to use it. Magic. Don't know what it does. That's a whole different question. I can go look at the docs for that, but at least I know I can call it correctly, pass it the right stuff, and know what type to expect back. Okay. You notice I got all kinds of errors here because when I pass this pattern to the constructor, I have to pass it as a string. This is going to end up giving me the same pattern. It will match the same things. They just behave a little differently in terms of where you use them and what methods you can call on them, but they do the same thing. Generally speaking, and I would say for the entirety of this module, use literals. So if you're using a regex, do it like this. For instance, another fun one here. This one, anybody know what this one's going to match? That would be like a real world thing you might have seen before in your life.
Zip code, full zip code 5-4.
That is exactly what it is. It's a zip code plus 4 validator right there. Has to be 5 digits plus a literal dash plus 4 more digits. So there are also ways we could modify that pattern to say the dash and the other 4 digits are optional. But we're not going to get into that. We'd be doing a class on regex at that point. But this is the basic idea. Generally speaking, writing them as literals like this are more performant. So that should be your default. They're also simpler to read. So just do that all the time until you have some reason you need to learn the regex object, is my advice there. Good. Cool, great questions. All right. So function signature there. This is what we call a function declaration syntax in JavaScript, which just means we're using the word function and then optionally a name. You can write what's called an anonymous function by doing just this. That's a function too. This is totally a valid function. It just has no name. So I can't call it anywhere else. So you'd only ever do this because you're going to call it immediately, either because you're passing it to some other function that takes a function as an argument, or doing this fun thing called an IIFE, which I'm not going to dig into too much, but it just stands for immediately invoked function expression, which means you create a function and call it immediately, have it call itself. So it doesn't need a name because it's just getting run. That's a more advanced and nuanced thing we don't really need to dig into too much here. And it looks a little weird, but I'll show you what it looks like real quick when we get into expressions here in a second. Okay, so this is function declaration syntax. There is another way in modern JavaScript to write a function, and that is as a function expression. Anybody know what an expression is in programming terms?
Formula?
It can be a formula. That's an example. So the ultimate like broad technical definition of an expression is a chunk of code that can be evaluated down to a single value. That's it. That's all it means. So when you define a variable and assign and initialize it to a value, that is an expression because the end result of that is the value of the variable, right? So when we talk about function expressions in JavaScript, all we're really saying is we're going to make a variable name and store a function in it. And in this case, the value we're resolving down to is the definition of the function itself. So the value is a function. Not the return value of the function, but the function itself is the value. So when we write a function expression, we write it like this. This is also sometimes referred to as arrow function syntax. So this means basically the same thing, okay? So now the variable name that I initialized, notice I use const here, right? The const descriptive other function name is essentially my function name. So if I want to call this later, I'm still just going to do descriptive other function name, and we'll assume that parameter is a string. So I'll call it with foo because I know it needs a parameter, right? So this is just like I would call this one up here by saying descriptive function name, right? So calling them works the same by and large. So for the most part, the only reason to use one or the other is that they have like the arrow function syntax is a little terser. There's less words, less characters to look at. I generally use the function declaration syntax all of the time if I am actually defining a function. And I use the arrow function syntax personally when I am creating anonymous functions, and rarely do I mix the two. And the reason for me is I like being able to see really easily that descriptive function name is a function. And if I see const in front of something, it's probably a variable I'm storing a value in, and I don't really want to have to also make my brain consider those as functions unless I have to. You're welcome to do whatever makes sense to you. There are a couple distinctions between these two, and we're going to get into that here in just a second. But personally, my preference is to use function declaration syntax, except when I have a good reason not to.
How do you type that arrow character?
It is equals, and let me see if I can get it to show you me typing it without the, it's that equals, and then the greater than, less than, the right angle bracket. I'll use that word. So it's just an equal sign and an angle bracket. My code ligatures just merge that together. It is this and then that, but if I take the space out, it's gonna merge them together. Let's talk about some of those differences now between the two syntaxes. So with an arrow function, and only with this arrow function syntax, there are two ways to return a value. In the function declaration syntax up here, the only way for me to return anything from this function is to write the return keyword and then, you know, return whatever it is that I'm returning, whatever value it is. In an arrow function, I can do the exact same thing. So I can return foo or return X here or whatever. If all I'm doing is returning this value and the function doesn't do anything complicated on the inside, and I can fit it all on one line without it being ridiculous, I can use what's called an implicit return. And that would look like this. I'll go ahead and leave it exactly the same for all other intents and purposes. Those two are identical for all intents and purposes. So if you do not open a set of curly braces after the arrow, you just put a value there. That's the same as opening curly braces and writing return and putting the value in there. It will just return the thing after the arrow. And you can see how this starts to make these functions get really short, especially if I don't need it to have a name. And that's where I think arrow functions are most useful, and we'll see that in a second.
How is that different from a variable?
It isn't, except that the value of the variable is a function. So this variable is callable. So if I do const x equals 6 and const some function equals, let's return the value of x. That's fine. I cannot do this. That's invalid JavaScript. But I can do this. That's the only difference between the two. Otherwise, it is just so a function expression is just a variable that holds a function. That's it.
Okay.
Okay. So when we do it this way, this is what we call implicit return, where we don't have curly braces and we're just passing the arrow. If you have to spread this out onto multiple lines, you can use parentheses here to do a multi-line return. But I would just avoid that at the plague at all costs, because you're just going to get confused at some point about what's really being returned. But sometimes you need that. Like, let's say I wanted this to return an object. That's primarily the use case for that, because how do we define just an object literal? Just curly braces, right? Well, so how do I have this thing? Like, if I just want this function to return an empty object, like, we'll call this give me empty object. And so I don't need it to take any parameters, because I don't need to tell it anything to give me an empty object. So there's a function that should hand me back an empty object with an implicit return. But JavaScript's about to get confused, because curly braces also mean something else here, which is now I can write a function. And what I really would have to do here is this. Now I will get a function that returns an empty object. Okay. But if I don't want to have to do this whole, now this is 3 lines of code, and I'm still just returning an empty object, that's where the parentheses come in handy. So I could do this, and now it will treat that as whatever's between the parentheses is the whole return value. So it's just going to return an empty object. And you notice they changed color. The parentheses are purple now on my screen instead of yellow before. Whereas when I did this, it's part of the function definition. Okay. So if I needed this to return a function or an object with some properties in it, like name, like that would be fine, but I have to wrap it. If I'm using an implicit return, I have to wrap it in parentheses, because if I do this, this is invalid JavaScript now, because this is now just a line in a function. So it's really like I wrote this, and JavaScript doesn't know what to do with just writing this as a line of code. It doesn't mean anything. Does that make sense? Don't worry if that boggles your mind a little bit about the implicit explicit return thing and the and the parentheses bit. For the most part, I think for now, if you just get used to the idea that if you open curly braces and you want to return something, you have to actually explicitly say return. And if you don't open curly braces and you just want it to return a value, then it just will return. The return is implicit at that point. Okay. So that's implicit versus explicit return. That only applies to arrow functions. You can't do any kind of implicit return from a function declaration. The other core difference here, which I'm going to scroll way down to, is right here, and then I'll touch back on it again if we have time, is hoisting and context. Okay, we're not going to talk about context yet. We'll get to that in a second, but I do want to talk about hoisting, because this one will throw you for a loop if you start playing with arrow functions and don't realize it's a thing. So we mentioned on day one that JavaScript has an engine, the V8 engine in Chrome or whatever it is, that reads your JavaScript code and runs it in real time, because you don't have any kind of compiler step. JavaScript is a script, like a play script. You're giving it to the browser to read and run, right? Do what it says. So when we are parsing that JavaScript file, it does something special on the initial reading of that file known as function hoisting. So what it will do is look at the entire file before it runs any code for any place where you use the keyword function at the root level. And it will say, oh, this code has a function called descriptive function name in it, so I know that exists. It does not do that with arrow functions, because as somebody pointed out, they're getting initialized as variables effectively. So it'll just treat this like a regular variable and initialize this when it gets to it in the code. Anybody have an idea of where that might mean these two get used very differently? Hint, order matters. Okay, I'm gonna give it to you. So functions declared with the function declaration syntax, so the keyword function, will get hoisted essentially. So you can think of it as if they were all written at the very top of the file, no matter where you put them. So you can put them at the very end of your file, which is often what I do. And then my code at the top of the file is what's actually happening. And it just calls functions that are defined somewhere else, so that the code's easier to read. With a arrow function syntax or function expression, you cannot use it before you've defined it. It would just be like trying to access a variable before you defined it. So if you're using this function expression syntax, you have to write this before you ever call it. So if in my JavaScript file I did this, descriptive other function name, this would throw an error because this function is not defined yet. But up here, I can 100% just do, and that's totally valid. Okay. So functions declared with the function keyword get hoisted to the top of the file when the file gets read. Arrow functions declared as expressions do not. So you can't call them till after you declare them. These you can call anywhere you want. Okay. So that's function hoisting.
So just a quick recap. Basically, if you call the function, it will read it through once and it kind of knows the function exists, and so it hoists it, and so it will do it. But if you do it as a variable, the order matters. Did I get that right?
Yes, with one minor correction. So at the beginning,
Okay.
you said if you call the function. We're not calling this
Oh,
function
yeah,
here,
yeah,
we're
yeah.
just declaring it. Okay,
That's
so this
okay,
is what's called
yeah.
a keyword, right? So in here, we're using the function keyword. And so when you first load a JavaScript file, the JavaScript engine will look at the whole file for any place you use the function keyword and go, ah, I know this function exists and here's its signature. It takes these arguments and returns this type.
Okay,
It
fair
won't
enough.
call it or run it or do anything else with it. It'll just say, I know this exists.
Okay,
If you don't
Just
have the
kinda
function keyword in front of it, then it just gets defined like any other variable. So you can't use it until after it's defined.
okay, fair enough. Thank you.
You got it. Okay. I'm gonna breeze through this part real quick and you all can review this. This will all be pushed up and in the curriculum syllabus if you have questions, but this is gonna be a quick 1-minute overview on good function practices because I want to make sure we get into some of the array stuff we talked about last class and why functions and arrow functions become really useful here. So a conditional early return is a thing that is a very common pattern you will see. The idea of an early return is just to say, let's say I have this function and this function has, you know, not like 90 lines of code in it, but I only like 80 of those lines of code. Let's see, I'll write it out this way. If do all the things, lots of code, right? Well, maybe what I want to do is, this is being weird. Okay. Maybe there's a check here on if I'm supposed to do all of the things. And rather than check this way, the other option is just write the lots of code here. And then say, if not do lots of things, return. Okay. And so if this value is false, this code will never get run. So just kind of, and it doesn't mean you don't necessarily have to be using a not here. We're just checking like if a condition means we should stop looking at the rest of the code. One of the habits people will often get into is like, if this code is only supposed to run, if this lots of code is only supposed to run under a certain condition, you'll wrap it in an if check, right? And be like, okay, if something happens here, like, but if this is like, if lots of code here is like 300 lines in this function, and you have to nest it all in and indent it all one layer just to wrap it in this if check, it's often a better pattern to just check if you should even look at that code and just return if you shouldn't. Because nothing, once you've returned, this function has exited and gone back to wherever you called it from in the code. Okay. So that's the idea of an early return. Go ahead and get those things in there. Side effects. So the definition of a side effect is when you call a function and it changes some state elsewhere in the application. Meaning I call a function and it changes the value of a variable, that is a side effect. If it changes the value of a variable outside of the function, right? Like functions that are considered pure functions have 0 side effects. So anything they need to know about gets passed in as an argument when they're called. And any value they're supposed to give back to the application gets returned as a return value. And they don't directly update or mutate any variables or state outside of themselves. That's what a pure function is. Generally speaking, the purer your functions are, the easier your code will be to read, follow, and debug. So try to do that whenever possible. That said, sometimes it's useful to have a function that changes a variable. You wrote plenty of those in your RPG. So if a function has a side effect, my advice is it should only have side effects and not return anything. And vice versa. If your function returns something, it should have no side effects. And I'm hoping that this is starting to knock together in your brain somewhere where you're seeing why that would be true. If my function's going to hand me back the result of something, that's what I'm expecting it to do. That's its job. I don't want it to also have changed something else. Ooh, fireworks, that was exciting. I don't want it to also have changed something else in the middle of that process. And likewise, if this function changes stuff elsewhere in the app, I don't want to expect it to also give me a value back. So in addition to trying to keep your functions pure in terms of them getting handed everything they need and returning everything they're supposed to get back with no side effects, the other pro tip I have for you on thinking about functions is that they should only do one thing. That doesn't mean there's only one line of code in there, but you should be able to say in human readable language to me, like I'm 5 years old, this function's job is blank. And if what comes in that blank is more than a sentence, your function is doing too many things. It should be more than one function. Okay. Part of the whole point of using functions in our code is to create reusable blocks of code that are clear and easy to understand so that we can take all of the logic that does that operation and hide it inside the function, and everywhere else in our app, we just ask the app to do that thing. And so if your function does more than one thing, or the name of the function doesn't describe its purpose very well, you will start to create problems for yourself only because you won't be able to actually read your code. And this is why I keep coming back to the importance of reading code and reading function signatures in here. Readability is one of the most important metrics of the quality of your code. If you can't read your code and explain what it does, then your code needs work. And part of the reason for this, so it used to be way back in the day when programming was first a thing 50 years ago, CPU time, as in the processor doing stuff in your computer, was more expensive than people time. And that is because those early computers took up entire buildings and used immense amounts of electricity, and there weren't very many of them in the world. So if you wanted to go run a function on IBM's giant mainframe, that was going to cost some serious money, and every character you had to feed into that machine cost you more money. So the motivation there was make your code as short, as small, and as tiny as possible. So we would see variables that were all single letter names. Everything was X or Y or A or B. We would see functions with single letter names, things like that, to make the code footprint literally smaller. That all of those choices come with a cost, and that cost is that your code is extremely hard to read and follow because you're suddenly trying to keep track of 17 different one-letter names in your head and what the heck they mean. Nowadays, in modern programming, that has completely inverted. You're all joining me right now on probably a laptop or a desktop or your phone, all of which have more computing power than that original IBM mainframe did, and don't cost you anything to run another app on, really, other than a little battery life or whatever, right? However, as you all know, developers are expensive. And the harder you make that code for me to read, the longer it's going to take me to do anything for you, and my time is expensive. So it is way worth it to have longer function names and longer variable names and longer code if it makes it easier to read, because it means every developer that touches it, including future you, and you all have that to look forward to in 6 months when you go back and look at code you wrote a while ago and go, who the heck did this in here? This is dumb. And then you're like, oh, it was me from 6 months ago. That happens all the time. It happens to me on the regular at work. I'm like working on an app I haven't touched in a year, and I'm like, who the heck put this in here? And then I look at the Git blame, and it turns out it was past me. So do your future self a favor. Make your code easy to read. Name your functions after what they do, after what their job is. And if you have a really hard time figuring out what that name should be, that should also be a clue or a smell to you that your function is probably trying to do too much stuff, and you want to break it up into some smaller functions. Because remember, a function can always call other functions. So if your function does 7 things, take 6 of them and move them out into their own functions, and then have that one function call the other 6 functions as its job, right? It will become way easier to figure out your little bits of code one at a time. And then when you've defined a function with clear responsibilities, your problem you're trying to solve gets smaller, right? Now I just need to go make this one function work, and its only job is to return an empty object. Oh, that's easy. Okay, and this comes back to the beginning of class question about working on projects and starting from nothing. Often when I'm working on a blank page and starting to break a thing down, I will try to break down the steps of whatever it is I'm trying to do in my head in just some human readable comments. I will write no code. And then likely the very next thing that happens is all of those comments get turned either into a variable because I need to store some data, or into a function name because I need to do something. And I will often declare all those functions without them doing anything. It'll just be function name, whatever, parentheses, curly braces, carry on and declare the next one. And then that way I can write the main part of my app to say it's going to call this function to do this step, and it's going to call this function to do this step, and etc. And then that main code is short and easy to read, and the function names make it clear what's happening. And now all I have to do is actually go implement each of those functions, which means I'm doing tiny little tasks that are well defined instead of trying to build the whole app all at once. That is the power of breaking stuff up in functions and naming things well. Okay.
Quick question on that too. Obviously commenting and documentation layers in there. What do you see kind of in the real world as far as the amount of comments? I mean, I understand if you're a good developer and you make it readable, then comments might add extra time. Where do you strike that
I
balance?
love this question, and there is much debate on it in the field. However, I tend to come down with on the side of comments are actually a code smell. If you have to write comments, you probably should see if you can make your code more readable to not need the comments. That doesn't mean there is no place for comments. However, probably more than half the comments I've seen in the wild were comments that were there to explain what a function did because that function did 7 things and was poorly named. And the better choice than writing that comment would have been to rename the function and, if possible, refactor it.
Fair enough. Thank you.
So the good use case for comments is to explain why, not what. Okay.
Sure.
So at the top of a file, doing a nice big long doc block that says, hey, there's a class in here, and here's kind of an overview of like why this is even here. Or on top of a function, having a comment that says, this may seem like this is done in a weird way, but it needs to be this way for the following reasons, so that later on when you see it and you think you should just change it, you remember not to because there's a reason it's that way. Right. So like exceptional things or things that are out of the norm that can't really be fixed by naming, or things that, there's a particular rationale because you're working on a project for a client and they needed something to work a certain way that isn't the norm. Like those are great uses for comments, but comments that say this function does the following thing. Somebody shared an example with me the other day that was, I saw it like this. I see so much of that crap in the wild, and I swear to God, I hate it every time I see it, and I want to kill it with fire. You named your function well, and I got it. So my instinct is usually to want to go in and change that comment to say, everyone bask in the glow of my amazingly well-named function. That's really all that comment is doing, right? So just delete it, because I would way rather read that you're calling get results. And if up here in this function where I'm doing stuff, one of the things I do is get results. Guess what I think that function probably does? Probably gets the results.
All right, cool.
Right? So treat comments like a code smell, but absolutely write them if they will make something clearer. I tend to write a bunch of them at the beginning to think through steps for stuff, and then I delete them out as they get replaced with functions and variables.
Do
And
you
then I only
ever
go back and add them where necessary.
do you ever have like a user, like if the accounting department, someone told you something, or explained a formula well, would you maybe add that SME's name in there or something on relation to the comment, or would you then more refer to like the requirements document in the
Yeah,
BA?
that depends entirely on the project. And like if there's no documentation on the project, I might leave a link in there in the comment, a link to a library or a note about who to
Okay.
talk to about it or whatever. Again, those are process things that you can't just name in a variable. So that's useful.
Okay. So it's kind of culture and need and in that striking that balance, but not
Exactly.
like
And
you
if that
said.
hypothetical project had like really exhaustive documentation already, I would just go add it to the documentation and not write a code comment.
Perfect. Okay, fair enough. Thanks.
Every line of code you write, whether it's a comment or something else, is a liability. It's something you have to maintain. It's a place you could introduce a bug, and it's a place you could potentially confuse you or somebody else in the future. So only write it if you're clear why you're writing it. Otherwise, you're better off spending the time drawing diagrams or making notes to yourself and thinking about something to write less code and write less comments and make it clearer on its own. That's my advice there.
Okay, thank you.
You bet. Okay, so common smells that you're about to dive into bad function habits. Too many parameters, more than 3, problem. I really like them if they only have 1 or 2. If a function takes like 7 parameters, you're going to want to break that up somehow. Now, sometimes you do need a function to just have access to a crap ton of data. And at that point, the answer is a parameter object. So make it take 1 argument, which is an object that has all the stuff that function needs. Okay. Multiple responsibilities, we've already talked about. Side effects and return values. There, what I mean is having both in one function. If the function returns something, it should have no side effects. If it has side effects, it shouldn't return anything. Multiple return types, also a big smell for me. I see it in the wild and I hate it every time I run into it and I kill it with fire. A function should return 1 type. If it could return null or a string or undefined or a number, then everywhere you call it, if you're being defensive about your coding, you have to handle all of those types. Don't do it. You'll hate yourself later. All right, we got like 1 minute left, but thankfully I've already covered the homework bit. So I just want to talk a little bit about scope. So scope is what's happening between the curly braces of the function. So we have local scope inside the function and global scope outside the function. Okay. If you declare a variable inside a function, you have declared it in that function's local scope. So you can have a variable with the same name in the local scope that you do in the global scope, and they're two different variables. Because when that function finishes and those curly braces close, that variable gets garbage collected and destroyed. It goes away. And then the global variable would still be the answer at that point. Okay. So just think about the idea of scope as every time you create a function, while that function is running, it's like its own little miniature program. It can declare its own variables, etc. It can access variables from the outside. Then you're creating what's called a closure, but that's another topic we'll probably not get into till the next module. So just be aware of that. And that gets a little different between arrow functions and function declarations, but not in any way we need to worry about right now. So the last thing I kind of wanted to say about like the array methods we looked at, this is where I love arrow functions. So I mentioned that other class of, we dug into the ones that just take values, but I mentioned there was a chunk of array methods that take functions like filter, find, sort, map, etc. This is where arrow functions become really useful. So for instance, the find method will return the first value in a variable that, in an array that matches a truth test. And the truth test is just a function that will return true or false. Okay. So if I'm looking for the first item that has an ID that, or let's say where the name is my name, I could put a function in here as its argument that says it takes a name. And then I want to know, return the name. Let's see, this is going to be called an array. So the name in the array is equal to the name we passed into the, but these two things are the same. This is like a slight oversimplification of the thing because I haven't declared the whole method here, but I can pass a function in like this, but you can see that's like getting unwieldy in syntax already. So the much cleaner way for me to write that is to use the implicit return and the arrow function and just say, oops, got a space there already. Okay. So this becomes like much easier to read. So when you start playing with all those array methods like find, insert, and search, and sort, we don't need to name the function that's getting passed to them because we're never going to use it again. It's only here for this. So anonymous arrow functions are a great case there. And often you're doing something really simple like looking at the thing in the array and then returning true or false based on some condition. And maybe it's just whether or not two things are equal. That's really common in filter, for instance. So arrow functions with an implicit return are really useful for that because this little expression will evaluate to true or false since it's a comparison. And so this is just a function that's going to take each item in the array and it's going to say, is it equal to some other thing I've provided? And if so, return true. If not, it's going to return false. The last piece for the upcoming homework are these operators, which Google them if you get stuck on them. They're fairly straightforward, but these are Boolean operators, and this is going to be the whole topic for next Wednesday's class. I just didn't want you to not have any idea what they were. So double ampersand says and. It's true if the things on both sides are true. Double pipe is or. It's true if either side is true. And then the exclamation point we looked at briefly earlier is not. So it just takes a true and turns it into a false, or a false and turns it into a true. Okay. And then there's this idea of the ternary operator, which is just a short way of writing if true, do this, else do that. Okay. So if I have one of these really simple conditions where something is one way if it's true and a different way if it's false, I can rewrite the same thing using a ternary and just say, true, X, otherwise Y. Okay, so the question mark is the first if check. Then the next argument is the value to be returned if the thing before the question mark is true. And the thing after the colon is the thing returned if false. So you can just say, assuming I'm in some condition, If some condition is true, I'll get X back. If it's false, I'll get Y back. That's how you write a ternary operator. And they ask you to write one in that exercise. So I just wanted you to know what a ternary operator was. I think that's where we're going to tap out because we're 4 minutes past now. I'm happy to hang out for 10 to 15 minutes and answer any questions anybody has. But otherwise, just fire away at finishing up the form validation if you haven't, and moving on to project number 3 in there, which is the music player. And I will see you all on Saturday to work on Coffee Shop.
Woo. Thanks, Eric.
Thanks, everybody.
Yeah, thanks. Good stuff. Appreciate it.
You betcha.
Thanks. See ya.
Eric, I have a question for you.
Yeah, fire away, man.
Like I can do and I know how to put in the code, but how do I get into like using, because I understand things better by using like real world examples, like the way we did the dragon fighting code. That one was helpful because like I know when I do it and then I go and play on the game, it works.
Mm-hmm.
But sometimes when we get lost deep into the code, without real life examples, I kind of get lost because I see what you're saying, but I'm like, okay, but how would I apply like in real world applications when I'm trying to put it in there, like an example? So how would I go about, like, is the best way like the way we usually go and look at the console and pages to see how the code works? Or
For these basic like right now, part of those are great questions, and part of it right now is that we, by the nature of being so early on in this learning process on JavaScript, we're focusing a lot on just getting the syntax all in there so you have the tools to play with. And you're absolutely right that if you don't apply them, they're not going to stick. When it comes to just playing with simple functions, that is almost always where I reach for that REPL. So in the browser console or in Node on the command line, if you've installed Node, either way works. But I will often, like if I just want to make sure I understand like how array find works, for instance, like I will, here, let's just do a quick example. If I was like, I think I understand how array find works, I would just open myself up a browser console here, or Node in this case. Let me clear all this stuff out. And then I'd just be like, cool, I don't know. So let's like make up some random array. So I'll just call it array. Actually, I'll call it ARR. I think array is a reserved keyword. And we'll say, let's put some numbers in there, and we'll put some strings in there for funsies. Okay, cool. So I've made myself an array I can play with now. I can call that whenever I want. I have an array. Now I can play with array methods. So let's play with how find works. Let's say I want to find the first even number in the array. I'm going to do array.find, and now this takes a function. And you can see it's yelling me right now that I'm missing argument 0 because it needs a thing. So our little function in here is going to get handed each element of the array. So I need to give it a name for what I want to call those things. So I'm just going to call it item. And then what I want to know is that item even? Well, the way I would check even is if I divide it by 2, is the remainder 0, right? So I can do item divided by 2 equal, and then get the remainder, or there's a special operator for this, which is the modulo operator. So that returns the remainder of the division instead of the result of the division. I do item mod 2 equals 0. Okay. And when I do that, what's going to happen is it's going to pass 1 in here, and it's going to say 1 mod 2 equals 0 is false because 1's odd. The remainder of 1 mod 2 is 1. So this is false. So don't return it. It's going to go on to the next one. It's going to pass in 2. So now the value of item will be 2. Item 2 as 2 mod 2 is 0. So it's true. So it's going to return 2 and stop. It will never evaluate the rest of the array in this case.
okay.
Because find returns the first one it finds. Okay. So let's say I want to look at filter and how filter works. Filter takes a callback also. And let's say I only want the strings. So in this case, I'm going to say again, we'll just call them item. And I want item instance of, which is Actually, we'll do type of. There's two ways to kind of check this. They're slightly different. Type of item equals string. And now if I run that, you can see it's highlighting what my return value is, but I can hit enter and actually get it. Now I get back a new array that is just the strings. My original array is untouched because filter returns a new array, it doesn't mutate. So array is still this, but that's how filter works, right? And so that makes it easy for me to kind of go like test my knowledge by just creating like a really simple example of a data structure and then playing with the things I can do to it.
Okay, yeah, just like isolating that specific thing you learned and then going to like Node and testing it out and see how it works out for you. Okay.
Exactly. And then if I think I have like a slightly bigger idea, like, oh, I see how I could use that in a web page or an app, then
Mhm.
go spin up an index.html real quick, chuck it in there, build yourself a button and make the button do a thing, you know?
Okay, that helped a lot. Yeah,
Yeah,
that's
try to keep those test cases as small as possible, right? Like just test your knowledge of the method and then apply it in like the world's dumbest thing. Like I make a div and I change the text in it with a button like we did in the Dragon game, but I'm going to change that text in a number of different ways because I'm trying to understand find better or filter better. And so it's a very scientific method for me. Like I have a hypothesis. I think filter works like this. Can I test that? Sure. Like write an example of that real quick and see if it actually returns what you expect.
okay. That helps a lot. Thank you so much.
You bet.
Yeah, because I end up getting deep into my code and then I'm like, wait, where am I? So I think
And in that case, I even actually will like back out to this approach. So if I've written a
Yeah.
bunch of code, I'm actually working on a project or a little app, and
Yeah.
some part of it isn't working, and I've written too much code since it was last working, and I'm not sure where to debug it. I'll grab like the most complicated part of it and see if I can just chuck like copy and paste that out into a console and see if it by itself does what I'm expecting.
Mm,
Right. And you kind of work through step by step through your code and be like, okay, this step's working right. This step's working right. Oh, I thought this was going to give me back a number, but it's giving me back a string. That's where my problem is. Right. And when you see the little piece that doesn't work when you test them in isolation, then it becomes easier to figure out what the real bug is in your larger project also. So even when I'm working on, big existing legacy code bases with hundreds and thousands of files and lines of code, if I'm working on some part of that big feature and some part of it doesn't work, I try to isolate that either by writing an automated test or pasting it out into a REPL like Node or the console or whatever and just say, okay, does this little part that I've just assumed is working right this whole time actually work the way I think it does? Because it saves you having to do all that extra setup just to test it.
that's right. All right. Thank you so much, Eric.
You bet. Anybody else?
No, that's a good question, Philip. That helps me too. Thank you.
Really great. Yeah, lean hard into small isolated examples that test your curiosity about it, right? Like, does it work like this? And how can you break it is also a great testing, right? Like, well, what happens if I like pass in something else here or try this a different way? So it's easy to, and a reminder when you're working in both your terminal and in the browser console, the up arrow and down arrow will navigate through your history. So if I want to just get like something I've done before again, I can get back to what I've done and just call it again without having to type it all out again. I mean, this is going to go back for quite a ways. We're getting back into stuff I've been testing on other apps now, but you can see all the kind of stuff I type in here. Like here's an example where these are two ISO 8601 timestamps that the data object produces. And I was trying to determine if one was less than the other, and my brain had stared at it long enough that I just was having a hard time reading the string. And it's like, it's gonna be a lot easier. Let me grab these two strings and paste them and put a less than between it. And if it's true, then this one's less than that one. I don't have to think about it anymore. So
Okay.
console is super useful, or the Node REPL if you're working in the back end of your terminal, whichever one is just, they're kind of interchangeable. Just depends on what's quickest to get to.
Nice.
All right, fam. Well, I'm gonna bounce. Y'all hit me up with questions. Keep things coming in the Slack, and good luck and happy coding. And I will see you all on Saturday.
See you Saturday.
Eric.
Thank you.
See y'all Saturday.
Bye.
Mm-hmm.